Okay, we're back, and we were saying that the night it is that I remember the night is the night, and and the night is all about darkness. Of course, we now have you know ways, to, or maybe always that was the case. People, humans have had ways to have some lightning in the night. Well, going back to our question, when the night starts, I was thinking that it was at 7 p.m., but I suppose this changed now, taking into account the whole world. Most likely, this is not the case. So, it depends if for you is dark at 5 p.m., then you should be saying, well, it is night here. But maybe you are just guided by the numbers. And even if it is 5 o'clock p.m. and it is dark for you, and still you're saying it is the evening because it is 5 o'clock, even when all about all the surroundings are in the darkness. So you are in, it is the, maybe, I don't know, honestly. Maybe, uh, I don't know, because I don't know. As long as the darkness is is the period of, and it will be like that for about 8 hours at least, because if it is an eclipse, then it will be dark at noon, and you will not be able to say it is the night in here because it's noon. It's just an eclipse. Okay, that's it. Maybe we should. I said no introductions at the beginning, no nonsense at the beginning. No, a lot of wanderings. Well, what's the point of these videos anyway? Most likely this should be in the sitting on the edge of ruin and chat instead of building, instead of live coding. There's no coding here. We are just trying to do some mathematics. Um, what is my chalkboard? Here is. Now we are able to draw. Now the titles of these videos are a little bit I don't know. There were some internet interruptions. It's not 45 degrees. No, we're at the middle of this. It will take us entire night. So I'm okay with this. We have P. This is on radius. This is Q. This is the origin. This is the unit circle. Uh, we have, uh, we know PR, if P has coordinates P, if P has coordinates XY, we know that Y is PR. We did that elaboration yesterday in the night. Um, and this is an angle. It should be 40 degrees. I went too far with this. Sine 40 degrees. It's equal as y, this y, over the radius, which is the hypotenuse of this right triangle. And at the beginning, it was PR. In the case, you're not following videos, this is the segment PR, noted by PR, and then R. So it's very explicit that this segment is over this radius. But we found, the book, the author mentioned that Y is indeed PR. So, and it took us, right, I don't know, half an hour, 1 hour to know why. So we are using Y instead. So we have this little fellow here. The same goes for cosine, some same fashion, but you will use X. Oh my God, this is green. Let's just wrap this, to procrastinate. It is time now for us to open the book again. Trigonometry by M. Soul and M. Soul, and of course the guy Helfan, Israel Helfan, outstanding mathematician and educator. That's why I think I can say mathematician, but educator, the people say about his qualities on education. Well, I have never seen any conference or master class because I will not be able to understand. Uh, well, the books are outstanding. I haven't read too many books on mathematics, by the way. These are my first books. And thank God. It's great, like your first love if you've, uh, you know, well, that's this. Uh, it depends at which age you find the love of your life, then you're done. And hopefully for you, it was in your 20s. But if that was not the case, if it was late in life, well, I think it's outstanding. Uh, you get to experiment that feeling or state of mind. Maybe being in love maybe is a state of mind that you didn't know. I don't know. So let's hope we're here. We the mystery yesterday was that if we are going to find the information for the rotations in the next paragraph, or if we should be, if we are going to continue with this journey of finding, you know, the rotations. And let's get started. So we are here. We are reading the next paragraph. I'm trying to. This is not the best approach to read a book, especially a mathematics book. Well, I'm trying to show the entire thing, reading it on this fashion. At some point, they establish some similitude, so correspondence between an angle and the rotation of a given point. So do this exercise in your mind. Move this figure over here. This figure, you will take it in your mind and start moving like Yoda in Star Wars or whatever you like. Anakin, hopefully you like Yoda or the Jedi's. So you are going to use your mind, take this figure, these drawings, move it in your brain. Look, it's moving. Oh my God. And it's here now. This point ended on this place. I'm not drawing the thing here. You're going to do it in your mind. This point will end here. This point will end here. I'm helping you, trying to be helpful. This point will end here, right? So you move the figure, and then this point have a name. In here doesn't have a name, but in here it has. The circle doesn't like to have inhabitants without name. So now this thing is going to travel, and it performs. Since we don't know how the measure of this angle, they like to call them like this, theta, which is not a perfect circle. Okay, I'm going to get rid of this. I'm just making time. And they established I don't know how to say it, the similitudes or the correspondence. You can see they say that you can see an angle in a circle. I'm not sure if everywhere on the plane, or at least on the circles, you can see it as rotations. So this is a rotation of the point P of this measure theta. Okay, let me take a look again in here. So I'm not lying to you. So I make sure I'm not lying to you. So I can read from near, but I cannot read from far. Look at this. Now I need to take my glasses off. So we can associate. So if it's an association, you should look for that word in, you know, etymology, dictionary, I don't know. We can associate angles with rotations, even if the rotation exceeds 180 degrees. we sometimes talk about the angle instead of the rotation. Okay. We take an acute angle with one leg. And the explanation is that you can get from point P, you can get from point P to point Q by rotating. Maybe we should look for this word also in the dictionary. I mean, it's roots, their etymology, they say, uh, to see what they say, what they mean by movement. This is about motion. In this fashion of rotation, how mo- how rotation is a type of movement, maybe. Mhm. Picture a circle of radius one. We did it. The other leg will the measure of the second angle is say 40 degrees. Then we can get from point Q to point P by rotating through 40 degrees. This is important. We can get from point P, in our case, we can get, we can go from point P to point Q movement by rotating through, look at this word, through 40 degrees. It's quite a thing, this line of text. Here we go again from point Q to point P by rotating through 40 degrees. So we can associate angles with rotations, okay? So at some point they only will say angles instead of rotations. Now to the core of this chapter, I suppose, at least for us. Okay, you move this thing over here with your brain. That's amazing. Uh, so far we have said nothing new, or have we? Okay, we can use this observation to extend our definitions. In here there are angles and rotations. This chapter is about this thing, but they are still in the definition uh, stage. They are defining sine and cosine. We can use this observation, this, um, to extend our definition of sine and cosine. Let's write cosine. We were ignoring cosine the entire uh, day, the entire time. But let's write it. It's this ratio of OR over the radius in the same fashion of this. Okay. We can use this observation to extend our definitions of sine and cosine to our new angle. What which what new angles? Um, the ones that measure rotations. Okay, so it seems a rotation. are measured by angles. Oh, my glasses. Two are new angles, which measure rotations. Mm, this is a hard thing. So how do you measure the distance of 2 points? How do you measure the distance of these 2 points? How do you measure the distance of this line segment? At this point of time, we have agreed of some standard measured units. But if you were living back in the day, you have to agree with the people that you are communicating with, that you have to reach a point of consensus. Otherwise, you will be fighting, no, or not going anywhere. At some point of the human history, uh, maybe you can measure. Look at that word again, measure this line segment by having this unit segment and translating this unit segment as you did with here with this angle to this line. Look, you're going to move this thing again over here, over. You can draw points. And I move this unit segment with my brain over here, this point, and then here. Now I'm going to move it, this one over here, and then here, and then here, and then here. Okay, and you're going to agree with the people. Okay, this is going to be our unit measure. So this line segment measures one, two, three, four. For what? Four of these. And you can the other guy will say, since the other person agrees with you of this size of this unit segment, because at the beginning you were fighting. I want to be like this. So we have 10. And the other guy said, no, I wanted to be like this. So we have one. And you fight for a little bit. You argue. At the end, I don't know who is going to win. Maybe someone will throw a punch to the other. But this is the unique segment. Maybe the other use persuasion and say, look, this is the unique segment because of this, because of that, because of this, because it's good for you and it's good for the everybody. And they say, okay, I don't want to think. I want for you to think and just tell me, okay? So you ended accepting this. Uh, okay, so now you have four. Four of what? And then this guy is good, the one who won the argument. He is benevolent, right? And he says to you, or she says to you, look, I was, I went too far in the in the arguing, in the arguments. I let you have one thing. You get to decide the name of this thing. Oh, and the other guy says, oh, you are so good to me. Then let's call it, what? Let me think of some strange word. Uh, some sort of, what thing? How can we call this thing? E? Um, Let's use this thing, EJ, EY, uh, and EJA. So this is the EJA unit, all right? And the, the guy said, the other guy said, oh, it doesn't sound quite good, but I am benevolent, and this is good for you. Since I'm going to do more things, and you will have to accept those things. I'm giving you this. Okay, yeah, it's okay. So this line measures one, two, three, four EJAs. Four EJAs. All right? And everybody's happy now. And now everybody gets to construct. Everybody gets to build their houses using EJAs and using these measures, right? Then they invent instruments to have EJAs, all right? In that same sense, I am procrastinating. I don't want to enter into the number crunching and into the hard thinking of the trigonometry. So I'm having fun telling you these tales of unexisting worlds, right? In that same fashion, rotations are being measured by angles. I hope you get the idea. Linear angles, which measures, which measure rotations. Angles measure rotations, right? Don't repeat that too much. Suppose, yeah, kind of quick. Suppose a point P starts at position zero more drawing. Suppose a point P starts at position zero. Suppose a point P starts at position zero. Okay. Oh my God! Look at this. Look how beautiful this drawing is. Oh, but this is, oh my God, this is the unit circle. It only works for the unit circle. Let me, let me, uh, let me draw this for you. I'm very happy. As long as it is not this popular guy, but the only downside of this is that it was just throw at you. Look at this. Here's the thing. We didn't derive it. But we are not doing mathematics all the time because otherwise the application will not be shipped. I would like to ship the application and move to another application because we are software engineers at the end of the day. Even if you enjoyed mathematics, don't forget you are a software developer. I'm going to erase, and write this for you, and then we will perform some calculations, and hopefully that will make it. There will be one problem. If this is only about the unit circle, we will be on a square one. We will be at the square one. We will not be able to escape the unit circle popularity. And we will end doing some vectors and some linear algebra. And I don't want to do that for the time being. I mean, start to studying about that. So I'm going to erase all of this. You can erase all of this, right? I'm going to write the thing over here. Okay. We have my camera over here. Okay. Half an hour. We need some arrows. That's why you would like to love the truth, because by doing that, engaging in thinking, it will be hard to persuade you. They, you will need real hard data supporting whatever people are throwing at you. It's not because you are a skeptic, you are into skepticism. I don't know what the philosophy says, but it will be hard, to persuade you to. The one thing they will have with you is force, and that's all. But that doesn't mean that you will not be reasonable. You will be open-minded and accepting inputs, but very, you know, it will be not easy uh, to sell you um, points of views, points of view. Okay, let's engage in trigonometry. Most likely, this is the unit circle. Let's use this orange. Oh my God, over here, it was too much from here. Okay, you can draw and then move with the keyboard. I'm going to draw what is in the book, but we will do our own validations. So they say they have, so this is R0. Why is it R0? Because this is R is X, the component X, and it is a radius. Look at this from the origin. So this is at the origin, and this will be a problem. Uh, for a scenario, or is a scenario, but it's okay. Let's do some trigonometry anyway. So the radius and zero because the y component is at the level of x, at the level of zero, you know, the origin here. This is the origin. This is a point P, but it has no naming here. So it says that a point P starts at R0, the radius at 0, y, and, and rotates through an angle alpha. It starts there. It starts there, and it went one. Let me draw first the end point here. It ends here. So imagine this is a straight line, and the rotation went like this, and ended here. So this is alpha. Um, then this is the perpendicular line. This is x. Y. So this P was here. That's why it's not here anymore. It ended here. Maybe we can derive why is the case of this formula. This is R. Let me use some points to denote a product. Cosine of alpha. Well, this is not a product. This is an application of alpha, and then R sine of alpha. Sorry. From the previous drawing, you can spend a day or 2 days or a week uh, deriving this formula. Remember that we wanted to do that at the beginning, but we gave we gave way, as the Lord of the Rings says, we gave way. I don't know if that's modern English. We gave way. Uh, um, yes, we gave way. We gave up. Yeah, how to say that? And uh, uh, because we just did it for 1 hour, and because we are not at for this series to do mathematics by the sake of mathematics, we are doing these wanderings because we are trying to enjoy the journey of the building of the application. Uh, if you are really interested in mathematics, these little exercises, that's how you do mathematics. You have your previous drawing, and then you arrive at this formula, or even now that you know that you should arrive here, then how do I get from from what I have and arrive to this point. It will take you maybe a month. I don't know. You like this thing? It will be a good time for you. Uh, but we weren't so, invested in that activity. So we are using this quote unquote to say we gave up because we don't quit. We never give up, right? Stick with the thing till the very end. We are using this quote unquote because we're trying to say the thing as it were. Now enough talk, and let's use this for our purposes. Most likely this will be the unit circle. Let's go directly to the point. Why hesitate? Why start with why start with the easy thing? Let's go directly in what we were having trouble. Uh, let's use this. Okay. Um, let's say that this is a circle of radius 2. Radius 2. Radius is 2. So if this formula will work for us, this is correct. It is published here, but it is not guaranteed. You know that there's no guarantee that something is in the book is true. We are verifying. So if this radius is 2, and we want, so in this case, this point P is 2, 0. I'm not sure if you're seeing it. And now we want to arrive here. They are right at this point, but we want to arrive here. So we are going to rotate to an angle alpha of 180 degrees, like this, right? Going to move from here, rotate, and end here. So we are aiming to find -2. And here, I don't know if this is going to work because the other day I was reading uh, -2, 0. We need to find this, if this formula will work for us. If not, not a big deal. It just means that we should continue with our journey. And that's it. Let's use Q. So R, remember, I was telling you that these two functions, and I still don't want to say functions because I still in my mind there are those things are not functions yet. Uh, we are ratios. I am still in the stage of seeing these ratios in some triangle. I want to do the entire journey, which I ended seeing it as functions. So these these ratios um, in the realm of how do they say when you're measuring what the book doesn't say is that it should be on radians like the other book. When you're seeing these as functions, uh, their values range from -1 uh, 2, 1. I suppose that's the whole point of the multiplication here. Remember, we did multiply it by the radius. I don't know if you remember, uh, but let us calculate. Let us calculate. So r is 2 times r is 2 times cosine of alpha, cosine of alpha. Now we should use our calculator. And in here we're going to do uh, two branches, one with degrees and one with radians, because the book does not say, does not mention that the angles should be on radians. They are using degrees because 40 degrees on radians is another quantity involving the constant pi. But I suppose this thing will only work with radians. I think we are going to modify the formula. Let's try degrees. Degree, remember? Finding this radian was traumatic. Remember? Now we went right. We went straight to the point here to say, oh, radius degrees, he's here. It was a very traumatic experience. And this is mentioned on the Lord of the Rings, in which Gimli says to Pippin that he loves Pippin because how much it cost him to rescue him. And there was this, let's stop that branch of thinking. But yeah, don't fall into that trap. Even if it's something is very hard for you, you should be able to detach yourself from that. Even if it was a traumatic experience, even if it was an ordeal, find a way to say, hey, this not defines me. I am not this only experience, this soul experience. I am not attached to this person just because of this or because of that. Don't do that. It's a trap of the mind. You should be able to say, okay, I'm saying goodbye to you. You don't want just want it, you know? And, I don't know, whatever this, maybe some property. Okay, but still be able to value the things uh, in a measured way. Will be able to detach if it comes to that. Don't take your lives off, all right? Or any other crazy thing. Don't do it. It's not worth it. You're very worth it, right? Don't sacrifice. All right, let's stop the chit chat and 180 degrees. Let's use degrees. So let's find the cosine of alpha here, trigonometry section. It's not 1 or 0. Oh, minus 1. I was wrong again. Okay, what's wrong with you? Let's use radians. This thing should feels inverted. I remember the other time being the contrary of this. Well, let's go to degrees anyway. We are working with degrees. So cosine is 1. Minus 1. What's going on with me? Okay, let me be very sure. Alpha is 180 degrees. I'm becoming crazy. I'm going crazy. So cosine, look at this. This is because my screen is crazy. Cosine, I'm going to click cosine. Minus one. I like the number one to have this thing. Let us try it again. Number one is a beautiful number. Imagine that, saying that some numbers are more beautiful than other numbers. That's on you, that's in your mind. And oh, we're done. No more calculations because uh, our y component, oh no, we have to calculate sine of alpha. 180 degrees. Sine of a zero. I was thinking of this zero and this zero. It has nothing to do. So the other is 2, which is the radius. It has nothing to do with these two. It is the radius. It happens to be the point here. But we are going to do some calculations with points starting over here. We need to find some other circles. So 2 sine of alpha is 0. So Q is minus 2, 0. And we have arrived to our what we were aiming for this. We were longing for this. And you achieved the quest. The, as those guys say. Uh, well, maybe this is a happy path, as they say in programming. Maybe there is some sort of a book hidden in a unknown path to you. So we need to find it. You need to find it. You need to find just one number that does not follow this to win a medal prize, right? If you are into money making or recognition making, or, I don't know, or even fun making, nothing wrong to profit. We like to do that, but if no, you just need one thing that does not work. One simple number can throw away hundreds of work, hundreds of years of work. You just need one number uh, that does not work with a given formula that you find in any given book. You just need one number, and you will be. Uh, okay, let's try 90 degrees. In here, the coordinate would be 0, 2. Okay, we want 0, 2. But alpha now will be 90 degrees. Um, okay, here's the formula. I'm going to get rid of this. Maybe this. This stays. Now let's QPR. Oh, R is here. Oh, T. Maybe this is not a common name for a point, but it will be some of those names that you don't hear every day. Uh, so that will be R, which is 2 times cosine of alpha. 90 degrees cosine 0. So the whole thing becomes 0. And look at this. Then it was a good thing. If you are into some, if you are into, it was a good thing that we didn't make the thing work early. You should be, from 90 degrees sine. That's one. So the good thing about these two fellows, it will be 0, 1. No, there are some 40, 45 degrees that are 0.7. So that's 1 times 2, 1 times 2, 1 times 2, 1 times 2 is 2. We are right here, but maybe we are being lucky. So let's draw another circle. This guy. Let's draw another circle. What is the same color? Let's use white. So this radius, let's forget about this. So this radius is, what do you want to use? 5? We have a new radius. And now the point that we are going to look for is this, right? So we are aiming for uh, 0 minus 5. 0 minus 5. Maybe you are not seeing the coordinates because of my webcam. That's such life, said Steve Jobs. These are good quotes. Such life. And 0 minus 5. So let's see if this thing half works. It half works or it works completely. I'm not sure if it works completely. Or maybe half works some of the time, some others not. Okay, so let's see. Okay, so what angle is this fellow? Because we exemplified the thing with the 90 degree. We didn't with the 90. We did with 180 degrees. We're going to do it with this. I'm going to draw this and end it here. Mhm. So look at this 90 degrees, 180 degrees, 270 degrees. This is our alpha. This is our rotation. Yes. So let's use this. I'm going to reuse. Let's use you. Let's use you. Let's use you. Okay, let's use you. And uh, okay, let's use the formula. You don't have to memorize it. Radius is 5. Cosine of 100, 270 degrees, 0. Oh my God, thank God. And sine, minus 1, minus 1. Uh, minus 1 times 5. Oh my God, yeah. Don't forget your love of science. And we ended in the spot that we wanted. But these are things that we know. Now let's use 45 degrees and some other no angle 60 degrees. Yeah, 45 and 60 degrees would be okay. One other is a famous angle. Only two. And then we will move the circle. I think this formula does not work. If we move the circle on the origin, well, we will not verify that scenario, right? So let's get rid of all of this. So this thing works. Mm, When a formula works, then you can engrave the thing in golden characters, gold characters, gilded characters. How do you say that? With beautiful calligraphy that I don't have. Okay. So this point got merged with the circle of the big circle. No. Mm, okay, I'm very happy. Mm. Mhm. Let's see the time. 1 hour and a half. I don't know. Oh, this thing is almost over. 35 minutes. Half an hour. Let's do just the validation of 45 degrees, 60 degrees, and then start with the adapting this formula to mm, to a problem. Yeah, maybe tomorrow or the day after tomorrow because tomorrow most likely I will be with you 1 hour. I'm not committing 2 hours to this thing every day. So how can we find uh, friendly coordinates? Let's we find. So remember, I said that these guys are famous, and look at the results. And it makes sense because It was 1 for 180 degrees. So if this is the case, it should be 0.25 for 40, for 45 degrees. I don't think so. No, we saw this number is not enough to us. Okay, we need to see this thing. I will study. Now I am sold out with this book. So 60 degrees. 0.5. Hmm. Well, some problem in some book will say, a problem in some book will say, mm, well, I don't know. So if this has a radius of 10, it will be 10. The point here will be 10. And now we should be able to find the 60-degree point. We know that it should be on the first quadrant because it goes from 0 to 90 degrees, and then the second quadrant, third quadrant. So 60 degrees is here. And how do what do we know about the first quadrant? All the coordinates on the first quadrant are positive and greater than 0. Well, I just take the same. All the This happens when someone wants to sound knowledgeable. Look at what I've said. Other grants and the intonation also changes. Be careful. Uh, all the coordinates on the first quadrant are positive and greater than 0. This is just the same. I just said the same thing. And I don't know what else to say. There's nothing in my brain. So, so 10 is 0, so let's find radius times cosine of 60 degrees. This should be on 5. And 5 is the midpoint of this radius because it's 10, so it should be here. That should be this. Yes, this. I don't think this thing is going to work. And sine of 60 degree. It was the same? Oh, this is different. Hmm. Okay, now let's multiply this. That should be 8.5. We're not doing the multiplications yet, so it should be here. This is an approximation. So the point should be here. Well, that is no bueno because the point should end of the circumference. So now let's do the thing. By the way, this is not at the scale, so maybe we did something wrong with the drawings. So r, which is 10 cosine of alpha is 60 degrees. 0.5 times 10, that's 5. And then, how do you say that? Sine of 60 degrees. This is number 1.66. So, yeah, this is the 5. There is some instruments here, just in case you want to do it. Um, 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 like, uh, should be over here, almost 9. This is 9, this is 10, so almost 9. Just in the middle, but still, oh my God, here we are aiming for this at least. But if you take a look at this is by no means a 60-degree angle. Angle 70, 80, maybe it's 60 degrees, 70, 80 degrees, 90 degrees. So maybe it is over here. Can we use the instruments here? Mm. Just let's leave these things. Let's use the instruments. Okay, this is one. Oh my God. This is one. Come on. Oh my, look at this. It wasn't working. And look, and we will do something like this. Look at this. It's hard. These are hard problems. I'm not criticizing because I was thinking of this. When when we are about to draw our lines, we will need some constraints on the points that should be drawn. And it's a hard problem. So I'm not criticizing this guy. If you want to draw a horizontal line here, you have to come after all this space. And if you want to do it here, oh no, you cannot do it. And instead, you can move the mouse over here. I'm not trash talking the developers. It's hard. Okay. And some people just like to say, okay, you need to deliver this on the weekend. Oh, fine, give me a break. So this is one, this is two, this is three, this is four, this is five. This is one. These are approximated. Don't take this to the heart. We're going to use a small rotation. Okay, we're going to use 15 degrees. Maybe 50 degrees should be connected with the 60 degrees, 180 degrees. Well, let us see. And it's not. It is not. There's something in the, I say 15, yeah. Look at this. What about 10 degrees? These are, let's use 25 degrees. That will be 9. Mm, very over here. Uh, Now, there's something wrong in here. There's something wrong with this formula. Maybe you're not getting the formula right. Maybe we should go to ask Wolfram Alpha. Uh, 30 degrees. This should be of so which sort of rotations? 0.2. There's these big numbers. No, here's, and you can study these functions, how how they behave. So in here will be 8.7. You know what went wrong? That uh, we were trying to find a circle point, but this radius is not 10. This radius is 5. 1, 2, 3, 4, 5, 6 at most. And it's not centered at the origin. It's another consideration. Oh my god. So what was 40 degrees? Uh, mm, or 60 degrees. Oh, okay. Mm, this is so wrong. Don't do this. Do your drawings at scales when you are just validating what we did with the unit circle and the more friendly angles like 90 degrees and 180 degrees or 270 degrees, right? So you stop wasting people's time. Yes, there's something wrong. The point should be here, and we are aiming for this. But is circle centered? Shall I draw a circle in on my notebook and show you? If it should be able to. How can we draw a circle with certain radius in here? It's another problem that maybe this guy haven't solved. So they have a protractor. They have a ruler, and I remember. Oh, the ruler has the angle measured, and it's not here anymore. You can only have the ruler if you are in this. Look at this. So these things work. Uh, if the book if the circle is centered and and the scales of the units uh, the most precise that you can afford. Can we do that? 12 minutes. I don't have my compass. So if you, mm, just a minute. What are you? Okay, so I'm going to. We have this thing over here. Well, uh, I don't have big instruments, to move the camera and perform the circles on the drum. I can do that for you. Well, what can we do in 10 minutes? Mm, Let me look for my compass and my notebook. I have one notebook here. What is 15 months? Oh my God. 2 years ago, almost 3 years ago, I was starting reading that book on functions and graphs, not trigonometry, and I am in the same spot in that book. But, I should take note of what I do at every given point of the day. So when the time passed, I said to myself, I didn't do this because of that. This activity drained a lot of time from me. This event, some event took some time from me. Point. This is another notebook. And at different point of times, this is from July 2024. Same topic, functions and graphs. Then 2023, functions and graphs. It is good for me to take these things. Maybe at the end of my life, if I get the chance, I will write a book. My attempts to educate myself, to self-taught me mathematics. How it went for me. So, if someone is interested in the future, 200 years from now, a book exists, and they say, so this guy in this geography, at this point of time, did these attempts to know a little bit of mathematics. And, like, in order for the history. I'm a nobody. I will still remain the same. I don't care about that, but I'd like for the information to be there, you know, especially with this, with education, how the history of education has been. Some figures have uh, changed a lot of people's lives with their deeds, like Daphne Cooler. That person is a bless for this world, you know. Of course, I have my parents give me some great platform, uh, but still, I think there have been some challenges, and yeah, it will be great how the thing will end for me. And well, yeah, not to compare, but to contribute data. The education was people wanting education. I don't know. This how it went for this guy in this country in this point of time, and this is how this guy did it. This is another path that maybe you want to explore. People will continue to search for paths to educate themselves. People will continue to search for ways to, you know, we are we are very very intelligent creatures, right? This has been quite a journey. Okay, so let's draw a circular radius of 10. I'm going to open this. I cannot show you, but what can I do for you is to show you a blank page and show you the compass, opening the compass. I do have a video on the. Oh, okay, let's open the compass. 10 centimeters. There is no illas on this ruler. 10 centimeters. 10 centimeters. Oh, my compass got broke. I broke the compass. Look at this. I broke the thing. I managed to broke this instrument. Now this is a very bad thing to do. A very bad thing to happen live. I broke the thing live. I was thinking when I was opening the compass that since I am unemployed, in order to make money, I should be able to. Well, if you have the resources, the computational resources, you should be able to. And this was already said a lot of times. You should be able to encode the way you think, maybe, so you can sell a version of you, a digital version of you, like which people can, pay to interact with your digital version instead of your personal version. So in that fashion, if yeah, Oliver Heaviside. was alive at this point of time, and there were the computational resources to encode his personality, if that is possible, and the set of ideas that he can produce. Uh, we should be able to pay for a subscription and talk with Oliver Heaviside. And hey, Oliver Heaviside, how was your day today? I don't know how was the guy, how odd was the guy. They said it was an odd guy, but I don't know. For me, it is a great guy. So, hey, Oliver Heaviside, how do you feel about this thing in geometry? You will have answers approximated answers, not the real thing. It will never be real. The digital thing will never be real. Don't fool yourself. The real thing is a way different experience. It's a way different experience. It's the complete experience. But you can be content, or how do you say, be conform with the digital uh, version of your relation, even fake one, even approximated, because some people have boyfriends or girlfriends on the distance, and they chat and they video call themselves, and it's not the same thing. What is at least something, and but the thing that I just said to you is it will never be the real person. It will be a digital version. Um, the answers will be approximated, but with very good precision. Yeah, especially if you know the person, you will say yes. My girlfriend, if she says something like that, she will say something like that. Um, you should interact with your favorite artist, guitar player or singer, or, I don't know, soccer player, whatever, and it will not be the real person. It will be a digital version. The answers will be approximated with good precision, and you will conform. That's the whole point of this. How much are you willing to conform with these products? How much are you willing to live a fake relation with something? If not someone, with something, with some computer. How much are you willing to yield? This is a new word for me. Even if I am a software developer, this yield appears in JavaScript, um, in generators. Well, I don't remember. It's not in Python. But its meaning, I didn't care about the meaning of the word yield uh, until I read The Lord of the Rings. And how much are you willing to yield, uh, to conform with this something? These are not real. How much are you willing to live a fake thing and fool yourself if you are in such a need? If you are in such need, all right? I broke this thing. Let's fix it and let's land the Earth. Let's stop the daydreaming. Now let's fix this live. If it has, I don't think it has solution. I went too far with this. Then with the opening. Okay. I'm not good at doing this. I always ask for help to people when dealing with this, fixing things like this, or uh, I don't know, drilling the wall or something like that. I am not it. I don't like it. So I don't know how to fix this. Most likely, I will tell my sister or someone. Uh, because this is not broken. It is just. Let me take my glasses off. I'm not able to see. Okay. Another thing I didn't knew how it was before the breaking of the thing, so I don't have idea if I am doing it right. I will make a live streaming on fixing this. Okay, I have this compass, but it's not fixed yet. I will use force. Another thing is that I don't have. I am blind. The thing is fixed. Let's be very careful this time. And let's open for only five. Maybe five is too much for this compass. There was this song saying tears, tears, tears. Who is crying? How can someone be crying? Well, how do you need to feel to be crying? What things did you do to be crying? What you remembering? Okay, we have 5 centimeters, right? But these are, I don't know how you say it's perfect. And do geometry because it's good for the soul. I feel good making this drawing, you know. You should be seeing how I am drawing the thing. We have 2.5 because the diameter, no, the radius, oh yes, the radius is 5. Great. Now here, oh, right, look at this. We move our hands and we are seeing results. Thinking is not enough. Maybe that's why this Helfman quote some guy about the motion, how important is motion. Okay, 5 centimeters. Now let's use these things. Oh my god, I should have played the guitar. I hope you like these things. Guess what? I don't have a pen in here. And you will leave me? Yes, it's on. We need that pen. That's good. I don't have a pen in here. I took the pen from oh, it's there. This is of the time. This wasn't planned. It should be. I should be doing this. Well, I am into this thing. Just right. Yeah. Yeah. To draw some map. Now, how did you rotate your rule to be 90 degrees? For that, I'm going to use this. We can have the 90 degrees. This thing is kind of thing. You can spend your life with this. Believe me. Asking yourself question after question. Yeah, that will do it. Now, for the moment of truth. So this thing, I fixed the thing. Even if I don't like doing this, didn't ask for help. I fixed it. It's quite a thing, quite an achievement for me. You see? And now we know that we cannot go beyond 10 centimeters. Mm, and what do you think a person is crying now? Did that person lost someone dear? Is that person in depression? Why is that person in depression? Why someone will feel sad when you have trigonometry? Why Caleb, Caleb, or how do you want to call it, feel sad if I have geometry? There's no way for me to do that. I feel very sad when I lost my father, which was happened to be my only friend, right? That moment I feel sad. But right now, I mean, you have, I don't know, you have music. You can play the guitar. Don't feel sad. Let's suppose someone does not want to be with you. I told you before, detach. Uh, I say, well, I'm sorry, I cannot be that person. Uh, like maybe if these are your sons and they don't want to be with you, I don't know, I don't have sons. But at some point you broke the relationship because those are kids and they are not to blame. They are not equipped to take the decisions as adults. So at some point you broke the thing. So if they don't want to be with you, look my finger. Who? You. But to make mistakes, it's a human thing. So don't be too hard on you. Don't be too hard on you. Your sons will comprehend eventually that you were busy somehow. I don't know what else to do here. I would like to play the guitar instead. Oh yeah, we are finding 60 degrees friendly coordinates in a 5 centimeter radius. So let's find the 60 degrees. Hopefully it intersects the circle because if it doesn't, then we are done. No, we are done. We are trying to adapt this to a software problem, and if it works for the software and it does not work on paper, well, I'm sorry. I did some draws. I did some bad drawings. Cosine times 5, 2.5. But that's the easy part. I have my protractor here. This is the hard part. It will be 4.3. 4.33. Again, my glass of pizza. Can't believe these guys. In Veritas World, there is a device built by the entire history of humanity. People like Leslie Valiant in this reality, Daphne Kuller, Peter Norvig, some the guys from the mathematics, a lot of sciences, neurosciences, also biology, a lot of sciences. And then there was a lot of stupid people that took control over this device. It's a sad day, and for a sad thing to happen. Sad day for humanity. Well, these guys from the past, look at this. That's 60 degrees, and that's the point of intersection. So the formula, it is here on paper, maybe some millimeters, not even millimeters. I'm not sure if you're able to see. Well, they think they are geniuses. The ones in the Veritas world, they think of themselves like they are geniuses. Cannot believe it. I cannot believe it. I cannot believe it. I can't believe these people in Veritas world. You know the ones of the device. Uh, Look at this. We have this thing over here, right? And we are going to save this as an asset. Because this device in this Veritas world just uh, since these people is stupid or they are stupid, they are just stating the obvious. The next natural step for a smart guy to, well, not a smart guy, for the humans to make. If you're crossing the river. Back in the day, there was a little river, a little stream, yeah, a brook. I learned like 5 words related to water. The lot of the river. There was this thing. This is water. All right, and you're here. And there wasn't a school over here. My school wasn't like over here. There wasn't a school over here. My school it was on the side. But I need to pass over this thing because, uh, I have to do something here, like bring some food. But I was telling you that these stupid people in charge of the device behaves like this in Veritas world. This is a big stone. This is a small stone, and this is the end of the stone. So you're leaping in this over this stone. One leap, another leap. Oh my God! Another leap over here. You're very careful with you can follow this dirty water. And then this is how these stupid guys behave. They induced doubts on people's brain, on Veritas Pro citizens. And the follow. You are here now. The next natural step for you, the obvious thing to do for you is to go over this stone, because this is too small and you are unable to reach this one. The risk of falling is too much. So these stupid guys wrote in their little screens, and they wrote their command. Maybe I don't know how. I am yet to define how the interface of the apparatus, because writing on a keyboard is so 80s. So maybe they communicate with the brain. I don't know. I'm yet to define that. So they type the command. Go over here, live over here. And they send the dog on these people's brain. And this guy is aware, like Verita. You say, okay, this is stupid. This is nonsense. Of course, I'm going this stone because if I go this way, I will fall and I cannot reach this stone. So why in the world are you telling me this? Why in the world are you telling me something that I don't know? This is the next natural step. This is the logical thing to do. This is the obvious thing to do. It's pure obvious things. These people are so, I don't know, so medieval. And they are in charge of the apparatus in the veritable world. Not even medieval, like worst. And then you go over here, and then you reach the food, right? It's a pineapple. Beautiful fruit, very tasty. All right. Then you come back. Well, you can take the other streets. There are other streets, and then you reach. This is a shortcut for this place, but then you can go over here, go here. All right. This is a very tasty fruit. The tasty pineapple. You will get not disappointed. You need to taste it. You need to try it. You need to taste it. You will not be disappointed. You will be disappointed of the operators of this apparatus. This device so sophisticated in terms of science. They managed to render it as the most. I don't know. I'm very happy of being able to write Veritas World because it's the best thing that had comes to my mind in my entire life. Being able to think about Veritas World is, oh my God, is I don't know. It's like looking in other people's brain. It's amazing without having this device. I just imagining things and just daydreaming. So I hope you guys enjoyed. I'm leaving. 2 hours and 50 minutes. Nine. I'm going to talk in Spanish because I am from Mexico. 9 p.m. Now is the night. No doubt. No doubt. I'm going to play the guitar. Okay, have fun. And tomorrow, we are not going to do, more circles like here. Oh my, let's use orange. We are not drawing a circle over here. Oh my God, look at this. We are not drawing a circle over here and perform. You can do it. You can have your origin over here, your radius, uh, some rotation angle, and you can come up with beautiful drawings and use this drawing on your designs of your t-shirts because geometry. Look at this, just two circles, and now how cool this looks. Just two circles and a line. It is beautiful. Geometry is pure. I don't know how to even describe you how cool this looks like. There are just two circles and some lines in here, and you can rotate this and say this is a disk and it is rotated all over this circle and have some sort of device in which people can sit over here and be rotating on this circle and they will be over screaming and being happy at the end of the journey, at the end of the ride. Look at this. They will be rotating. They will be at some point stop here and they will scream. And they will reach this point. Then they will get off the game, or I don't know how to say this. And they will go home and remember this experience. Say, oh my God, that thing was quite a thing. And you will be delivering these experiences to people, right? Goodbye. We are not doing these experiments. You can do it on your own. we need to move to the software part with these um, equations. No, with this formula. Yeah, it's a formula. Bye. Thank you very much. Why I'm doing this? Oh my God, what is it says? I should stop the streaming. But I was closing this thing instead. So even if no one is here, I'm very nervous. Not nervous, I'm just messing with you. There were some interruptions at the beginning. Oh, one eight views and one live viewer. Thank you very much. We are saying goodbye. Thank you. Have a good night. Have a good night, this viewer. We love you. Thank you for your support. For real.